All right, guys, good morning. So, what I decided to do was instead of moving on, because a lot of you had sent me a whole bunch of different questions for the normal distribution stuff, I figured that we would do a little bit of practice with that. One of the big questions that I was getting was how do you figure out the percentages on the normal curve or the normal distribution? Those are always going to be the case, and that's why you can only do this for a normal curve. If we were skewed positively or negatively, right, if there were a tail to the left to the right, we would not be able to do this, okay? So whenever you're given a normal curve question, you are always going to be using those same percentages, okay? If you were to have a Regents exam, that would not be given to you, okay? So because your tests right now are on Delta Math, you have it obviously, so you can use it. But just know that next year, if you go into college stats, you may need to do a little bit of memorizing with that, okay? The other question that I was getting was a lot of you were going, instead of going by the half standard deviations, you were going by the full ones, okay? So let's just start with this first question, and I'll show you how to label everything on your chart. A test was given to 120 students. The scores approximated a normal distribution, meaning that you can actually do this curve for it. The mean score was a 78 with a standard deviation of 6. Fine, okay? Choice A, draw a normal curve that represents this data distribution. The top part does not even matter. Like the actual question does not even matter for the setup right now. It will in a minute, but once we get the setup going, you really don't need it until you get to your final step with putting your curve together. So for number 1, this is what you're going to do. The middle part here, this is your mean. Then we are going to go 1 standard deviation, 2 standard deviations, 3 standard deviations positively, and we're going to do the same thing going the opposite way. So we're going to have minus 1 standard deviation, minus 2 standard deviations, and minus 3 standard deviations. Now I just said though that we always go by halves, right? If you try to fill in all of these with the percentages, it's not going to work because they gave you a lot more than just these few, okay? So we're going to go in and we're going to put half standard deviations in there. What that means, instead of jumping from the mean to positive 1 standard deviation to the right, we're going to go from the mean to positive half a standard deviation, and then negative a half standard deviation. Then we're going to go the next. This is going to be 1.5 standard deviations. And then we're going to have 2.5 standard deviations. Then we're going to do the same thing on the other side. Minus 2.5 standard deviations and minus, that should be minus 1.5. Minus 1.5 standard deviations and minus 2.5. Minus 1 and minus 2.5. Okay, and then you can fill in all of the percentages. So, to start, this is going to be 19.1, 19.1, and then 15, 15. And then you have 9.2, 9.2, 4.4, 4.4, 1.7, 1.7, 0.5, 0.5, and less than 0.1 for the ends, less than 0.1%. Okay? That's the setup, but now you have to fill in for the actual numbers, like where everything is. So that is specific to the question. So this says that the mean is a 78, and 1 standard deviation is 6, which means half of a standard deviation is 3. It's half of 6, right? So that means because our chart is going by halves, right? 0.5, then 1, then 1.5, then 2. Because we're going by halves, our actual curve for this specific example is going by 3. the scores are going by 3. So what that means, your mean, we just said, is 78. To go 0.5 standard deviations positive, you are taking 78 and adding whatever half of a standard deviation is for this specific question. So you're going to do 78 plus 3 is 81. Plus 3 is 84. Plus 3 is 87. Plus 3, plus 3, plus 3. Okay, so this makes sense because if you go from the mean right here to 1 standard deviation, again, the standard deviation is 6. So to go from the mean to positive 1 standard deviation, 78 add 6 and you get 84. Okay, then do the same thing. Again, because our graph is going by half standard deviations, you are going to subtract half a standard deviation at each little notch on our curve. So 78 minus 3 is 75. Minus 3 is 72. Minus 3, minus 3, minus 3, minus 3. Okay? So what this means, right, the amount of people that scored between a 72 and a 75, right, 72 is right here, 75 is right here, is 15% of people, okay? So if I were to broaden the range, I just add in all the percentages that I'm missing. So for example, letter B, what percentage of students earned less than a 72? So 72 is right here, right? So what less than, so it can go all the way down to a 0. So you're going to add that 0.1, and then you're going to keep going until you get to that 72 line, and you're not going to cross the line that represents a score of 72. So you have 0.1 plus 60 plus 0.5 plus 1.7 plus 4.4 plus 9.2, and then you hit that line that represents a score of 72. So you're not going to add the 15 to that. You add all these numbers together, and the percentage ends up being 15.9%. Okay? Letter C, what is the range of scores that represent the middle 95%? 95%, that's the empirical rule. If you remember from on Monday, I told you 68% is 1 standard deviation, 95% is 2, and 99.7 is 3 standard deviations. So you can either look at where -2 standard deviations are and +2 standard deviations are from your graph, or you can take the mean of 78 and subtract 2 standard deviations. So 78 minus 2, the standard deviation is 6. That gives me a score of 66. That's the low end. And then +2 standard deviations would give me a score of 90. So the range of scores is from 66 until 90, which if I look at my graph here, -2 standard deviations, I'm going to highlight it right here. That's a 66. +2 standard deviations is a 90. Okay, so 95% of students scored between a 66 and a 90. And then the last question, which of the following represents a score at the 93rd percentile? So percentiles we really didn't talk too much about. You add, to get percentiles, you start all the way to the left and you add up, okay? So if we're talking about scores like we are right now, like test grades, and let's say you score in the 10th percentile, you're really far below, okay? You would probably be somewhere between here, like -2 and 1.5 standard deviations behind, okay? Actually, it'd be a little closer to that, but still. So which of the following represents a score at the 93rd percentile? So the 93rd percentile, we know that that's going to be pretty far to the right because all of these numbers, all of the percentages add up to be 100%. So if you are in the middle, right, you're halfway through, that's the 50th percentile. The 50th percentile represents the mean, right? If you add all those percentages, the 50th percentile represents the mean. So if I keep adding, right, let's say I go over one more. So I add 19.1%. Now I'm at 69.1%. So I have to keep going. So after 19.1 would be 15. If I add that, I get 84.1. Still not at the 93rd. And now if I add the next one, it would be 9.2. And then that gives me 93.3 percentile. So I am going to be somewhere in here. Somewhere in here, okay? So between 84 and 87 would be a fair representation for the 93rd percentile. So my answer is choice 3. 72 is way too far to the left. 78, again, that's the mean, so that would be the 50th percentile. And 93 is way too far to the right. Okay, that would be in like the 99th percentile. Okay, and that's it. So I'm going to go through the second one a little bit faster than that. Again, the beginning, the setup is exactly the same. The only thing that changes is the numbers on the bottom. Okay, so this is going to be your mean. You have all these. That's your mean. We are going to go by halves again. So we have, this is 0.5, this is 1, 1.5, 2, 2.5, 3. That's the that's the right side. And then for the left side, we have minus a half, minus 1, minus 1.5, minus 2, minus 2.5, minus 3. And again, all of the percentages in here stay the same. I always start from the middle and I go out. So to start, it's going to be 19.1 on both sides, just like before. 19.1, 19.1, and then 15, 15, 9.2, 4.4, 1.7, 0.5, and then less than 0.1, less than 0.1. Okay, so now we're going to have to fill in the bottom. So to do that, we actually need the question. So this is talking about battery lifetime. The mean is 500 days, so the average, a battery will last for 500 days. The standard deviation is 62 days. So that's 1. Standard deviation is 62 days. Again, we go by halves. That means that a half a standard deviation, half of 62, is 31. Okay? So if I start with the mean is 500. I'm going to go to the right first. I'm going to add 31 at each notch. So 500 plus 31 is 531. Then we have 562. And then 593. $624. $655. And $686. And I'm going to do the same thing, but I'm going to subtract 31 each time. So starting with 500, 500 minus 31 is 469. Minus another 31 is 438. 407. 376. 345. And 314. Okay? All right. And that's my chart. Letter B, what is the probability? So, okay, probability is a little different because probability is less than 1, right? You can never have, the probability is going to be 5. right? That would be a 500% chance of something happening. So once we add all the percentage up, we just move the decimal over. Okay, not a big deal. So a battery's lifetime is between 376. I'm going to highlight this for us. 376 is right here. 376 and 469. So between these two lines, I have 4.4, 9.2, and 15. So I add all of those numbers up. 4.4 plus 9.2 plus 15. And that gives me 28.6%. But this is asking for the probability. So I move the decimal over 2 times to the right. I'm sorry, 2 times to the left. So this is 0.286. But it wants it round to the nearest hundredth, so really your answer should be 0.29. Okay? Letter C, what is the range of scores that represent the middle 99.7%? That's 3 standard deviations. So you can either look at your chart and say, okay, minus 3 standard deviations is 314. Positive 3 standard deviations is 686. You can do it that way, or just like before, you can take your mean, subtract 3 times whatever your standard deviation is. That will give you the 314. And then 500, your mean, plus 3 standard deviations will give you the upper boundary, 686. Okay? And letter D, which of these battery lifetimes can be expected to occur less than 3%? So if we look at 515, 515 would be somewhere between 500 and 531, which shows 19.1%, so it's not 1. Choice 2, 350. 350 falls between 345 and 376. That percentage is 1.7, so that's probably going to be my answer. Okay, if we keep going though, choice 3 is 600. 600 is between 593 and 624, which is 4.4%. And then 430 is between 407 and 438, which is 9.2%. So your answer is choice 2. Okay? Now, I hope this cleared things up a little bit. Now, the other thing that we're going to learn about next week is what happens if I ask you for, let's say, the probability or the percentage of battery lifetime that falls between, let's say, 510 and 550. Right? We don't fill in every single one. If it doesn't fall on one of the half standard deviations, then we can't do this whole curve thing. So that is actually going to require the calculator a little bit. Okay, so we'll talk about that next week though. Okay. Tomorrow, make sure you submit your notes for this. Tomorrow you're going to have a worksheet on this, more practice questions, and then Friday will be your test on Delta Math. Okay, have a great day.